In this video, we're going to work on problem number 8 from the rate of change worksheet. So you're filling up an empty bathtub. After 10 minutes, there's 10 gallons of water in the tub. Now, the original problem was asking you how fast was the tub filling up, but we're not answering that question this time. We're just using this problem to be able to set up a t-table and a graph and write an equation for this. We just want to describe the problem. So let's get started. Right on the left, I have this t-table. If looking at the problem, 10 minutes, we're talking about minutes in gallons. So remember, time, it always goes on the x-axis, so I've got that here. We're talking about gallons, that's going to go on the y-axis. So here's my gallons, here's my minutes. All right. So let's figure out what we got here. All right, so what that jumps out at me is after 10 minutes, there's 13 gallons. So in the time, I can put after 10 minutes, there's 13 gallons of water. Now we need 2 points to draw a line, so we need to figure out another point here. And that first sentence looks suspicious to me. Why did they tell us that we're filling up an empty bathtub? Why did they tell us that? Well, if the tub is empty, that means when they start, right, before no time has gone by, there's no water in the tub. So I can say after no time has gone by, there's no water in the tub. So now I have 2 points that I can draw the graph. So let's try to graph these guys. All right, so let's graph the time first, the 10, 13 point. Well, let's see, I got to fit at least 13 in here. So what I'm thinking is I can probably count by ones. Put up 3, 4, and this is 5. All right, I'm not going to put numbers on every one. I only care about some of them. 6, 7, 8, 9. Here's 10, right? 11, 12, 13, 14. This is 15. Good enough. That should be enough for what we want to do. And on the gallons, up and down, I have to go from 0 to 13. So I can probably squeeze those in counting by ones. So 1, 2, 3, 4. That guy's 5, just for reference. 6, 7, 8, 9, 10. And then 11, 12, and there's 13 right there, right? All right, so I can graph these 2 points now. So 10, 13, I'm going to go over to 10, right, which is right here, 5, 6, 7, 8, 9, 10. So this guy right here is 10. So I'm going to go straight up here. Remember, we were drawing lines, dotted lines in class. Fortunately, this is graph paper, so I don't really need those. And then 13 to draw the gallons, so I'm going to go straight across here. And I can see where those two cross, and it's right there. So there's the point. And remember, the coordinates we said were always, when we told where the location, x was first and then y was second. So the coordinates of this are 10, because we've gone 10 in the x direction, and the y coordinate is 13. Now we're going to do the same thing with the other point. Well, that's pretty easy, right? 0, 0. Remember, that's right here, what we call the origin. So that's this guy, 0, 0. So now I've got 2 points. That's all I need to draw the graph. So I draw a perfectly straight line as usual. And there's the graph. All right. So now we just have the equation. So what we did when we did those other problems, remember, we want to know how are these related? How is time and the gallons, how are they related? Remember, we did the first problem this morning in class where we talked about I think he was running a race, and after 3 hours, he'd run 15 miles. Remember that? And we said, how were those related? Well, we said if we divide the 15, if we divided that by 3, we came up with 5. And we said, okay, so that's how we realized that the miles were 5 times the hours. So we can do the same thing here. I'm going to take the 13 and divide it by 10. And this is going to give me 1.3. Trust me on that, right? So what that means is that the gallons, writing this in English, right, are 1.3 times the hours, or the minutes in this case. Right? The gallons are 1.3 times the minutes, right? We can see this from the table. So now we're going to shorten this up, right? Instead of writing all this, we're going to algebraize it, make it algebra-like. So instead of writing gallons, I'm going to put G. R tells me equals 1.3 times the number of minutes, and again, instead of writing the word minutes every time, I'm just going to write an M. So now, and we said, remember, we could, if I have a number times a letter times a variable, I can lose this guy, the times, because it's always times. So I could write this as 1.3 M. That's the equation for this guy. And remember, we could say if we wanted to figure out, say, after, let's say 5 minutes, right, how many gallons would be in the tub, but we could take our equation of 1.3 times the minutes, and instead of writing the minutes, we could write in there 5, because I want to figure out how many gallons would be in 5 minutes. If we do the multiplication, 5 times 1.3, that's about 6.5. So that means after 5 minutes, there's going to be 6.5 gallons of water in this tub. This is all I was asking you to do, so we're done here. I got the t-table, I got the graph, and I wrote the equation, right? That's all we're after. Done.